How you doing? I'm Mr. Rose, and as you can see, today we're going to talk about vectors. Now, we're not getting huge, deep conversation about vectors. We're going to do a little simple vector math, three-dimensional vector space, just because a lot of people are unfamiliar with the three-dimensional vector space, a little bit about IJK notation. But to start, essentially, we're going to talk about vectors, and we need to know what exactly is a vector. So this is important, perhaps the most important part of today's lesson.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh, ah! Goodness, it's so difficult sometimes to get the ball back inside. Woo!
So that's a vector. Piranha gun, not necessary. But again, a vector we know is a magnitude and a direction. We learned that in physics before. We pretended to know what that meant, but essentially a vector is a way that we can describe our three-dimensional space, right? We did everything in freshman physics in 2 dimensions. Now we're going to jump up the bar and we're going to talk about three-dimensional space, because we live in three-dimensional space as you look at me on your 2-dimensional screen. So a vector is just that. It's a quantity that has direction, it has a magnitude, and it is very good at determining the position of something relative to one another. That's the big part that we're going to talk about today, right? The vector is an arrow that points to a specific place in space. Again, we've talked about 2D vectors. Just again, as this is an introduction, I don't read PowerPoints to you. I will make all of these available. You can read them. I kind of go over and summarize as I go. The reason why I have, again, that big 3D is we're living life in 3D now. It's very exciting. So that means X, Y, and Z axis. All 3 axes, you may remember your right-hand rules. That's kind of what we're talking about here. And when we talk about the X, Y, and Z, that's I, J, and K notation. Now, I do want to note that I did not do this the perfect way. There should be little hats on here, a little I hat, J hat, and K hat, little TPs. And that stands for a unit vector, and that just means the direction. I was just having an issue with my PowerPoint. So now, reporting a vector. Any vector can be given in, like I said, X, Y, and Z axis, but we write it in I, J, K notation. So this vector literally means it is 6 units in the X direction, -4 units in the Y direction, and then 13 units, that's into the screen, in the Z direction. So that's what that means. This vector is pointing into that 3-dimensional space, right? It is everything we've ever done, just adding a unit. Now, a vector has a magnitude, and that magnitude we used to know of if I had X and Y, just taking the square root, Pythagorean theorem. We're doing the same thing, except Pythag now is X, Y, and Z. We still have a triangle when you think about it. Think of that vector in any way, shape, or form. My 3-dimensional arm, I have a plane, I have a triangle no matter what. So we still find the magnitude of that by using the Pythagorean theorem. Here we can see that I put in my 6, my -4, my 13, and we report that as the square root of 221 or 14.87, either one, whichever one you'd like. The 3D angle is where people are confused. How do I report an angle in 3D? Well, we don't need to. Remember, we are very specific in physics. We're giving reasons why we use things. So all we need to do is describe where you are with respect to a certain side, the x-axis, the y-axis, or the z-axis. So here I have all of my vector again. I just brought it over from the last page and again explained out in writing where this is. But now for that direction, well, again, if you picture my arm, and it's easiest about the x-axis. It doesn't, well, it would actually be down there with my negative, but I can't do that. And I can't draw it because of the broken hand surgery. But I have 3 dimensions here, and now my elbow is perpendicular, not perpendicular, but laying on the xy, on the x plane, not the xy plane, the x plane, this 3-dimensional x plane. So I can find that direction with my x direction right there. I went 6 units in the x direction, right? And I make this plane, this triangle with the x direction. So I'm just literally doing a cosine. Cosine is opposite over adjacent. Now I'm a liar. Cosine is adjacent over hypotenuse. It's been some summer. The adjacent side is my I in the x direction. The hypotenuse is now my magnitude of that vector. And I'm at 66.2 degrees with respect to the x-axis. That's all I would need to do. I can do the same thing in the y and the z-axis. I'm at 105 degrees with respect to the y-axis. Or I'm at 29 degrees with respect to the z-axis. Now, awesome. What if I have 2 vectors? Well, there can be questions where I have 2 vectors in 3-dimensional space that ask for a lot of things. So I can have 2 vectors. Often they'll want to know what is the angle in between those 2 vectors. Well, that angle, even though we've got these complex 3-dimensional vectors, there's A, ijk notation, there's B in ijk notation. So these random 3-dimensional vectors, no matter what, I have a 2-dimensional plane in between them. So I can figure out the angle in between those 2 vectors, assuming they both come from the origin. I can figure out if they're not from the origin, like, no, you can't do it. So assuming they're coming from the same place, either the origin, or you can define where they start as the origin. That's okay. We can figure out the angle in between them. Now this is just the dot product. A dot B equals the absolute value of A, or the magnitude of A, the magnitude of B cosine theta. Rearrange that, and now look at this. I can find the angle in between vector A and B. So first, my suggestion, first step is, if you want to do it in steps, find the dot product, A dot B. So that literally is 9 times 4 plus -7 times -3. I wrote that out for you. A dot B is x dot x, y dot y, z dot z. That's the dot product. And if you look at the cosine of the angle, you might be able to figure out why. Here, as long as I did my math right, A dot B is 107. We have no units because these are just numbers. The next step I said is solve for the magnitude. Well, we already did that on the last slide. The magnitude is just a Pythagorean theorem, so the square root of ijk. We get root 230 for A, we get root 50 for B, and now we put it together. I want to find theta, so I say cosine theta is equal to A dot B, 107, divided by my absolute value, or the magnitude of A, times the magnitude of B. Take the inverse cosine, I get an angle of 3.82 degrees. That is the angle in between these 2 vectors. And that's it. Vector space in 3-dimensional, in 3D. It's not as hard. Actually, my speaking was worse and more difficult than this is going to be for you, hopefully, mathematically. That's all I have for you. Hopefully you're watching this on my YouTube channel, so I like to say, please feel free to like, click, and subscribe. I do like to try and end some things with some fun physics puns. And I got nothing except vectors are coming at you. That's it, guys. Have a good day, and you will see me next time.